Hello, this is Dr. Mears. Today we are going to be going over Paper 1, Example 9. This is Paper 1, Example 9. And this is the example right here. Paper 1, Example 9 is a true geometry problem. It is, can you use Pythagorean theorem and can you use volume formula? The volume formula is definitely given in your formula booklet. However, the Pythagorean theorem is not. So let's get started. A right pyramid has apex V and rectangular base ABCD with the distance between A and B equaling 8 centimeters, the distance between B and C equaling 6 centimeters, and the distance between B and A equaling 13 centimeters. The vertical height of the pyramid is the distance between B and M. So this is a triangular right pyramid right here, and VM is the height. Here we have a rectangular base. AB is 8, BC is 6. We have VA is going to be 13. So they substituted all of the numbers in. That would be the first thing that I would do, so that's why I checked. Let's see what Part A is asking us to do now. Part A, it says calculate the distance between V and M. So what they're asking us to do is to find this height between V and M. Now I'm noticing a lot of nice right angles here. We have a right angle with the base right here. We also have right angles. We have a right angle right here. So what we're going to have to do definitely in order to find VM is we're going to have to find the distance of AM here. So do you see how this makes a nice right triangle here? I might want to get another color. So, all right, so we need to find the distance between V and M here. In order to find this distance, we're going to have to find the distance between A and M and use this triangle. Now, the distance between A and M isn't given. So that means that we're going to have to find another mystery side, and this mystery side is the distance between A and C. So right now I'm going to be looking for the distance between A and C. The reason why I wanted to do that is because I see that we have this nice right angle here. So I'm picking out this triangle for you. It is going to be A, C, B, back to A. And that's what we're going to be finding is this distance here. Once we have this distance, we'll be able to find AM. So because we have a right 90-degree triangle here, we're going to be using the Pythagorean theorem. So down in workings, this is for part A, we have A squared plus B squared equals C squared. So that's Pythagorean theorem. They do not give you that in your formula booklet. You do have to know that. So assigning sides, the two sides that are A and B are always the sides that make the right 90-degree angle. And this third side here is going to be side C, which is always across from the hypotenuse, which is the hypotenuse, which is always across from that 90-degree angle. So let's substitute our numbers in. A squared plus B squared equals C squared. So I did 8 squared plus 6 squared equals C squared. So I have 64 plus 36 equals C squared. Adding 64 and 36 together, I get 100. In order to find the value of C, I take the square root. Squaring the square root are inverse operations. So I find that this length between A and C right here is going to be 10. This equals 10. So this whole length equals 10. Now, since this whole length equals 10, and this is the midpoint, this M is the midpoint, can you guess what AM is? So if M is the midpoint of this whole entire thing and C is 10, then AM is going to be 5. So now what we're going to need to find is the distance between V and M. So we have VA, that's 13. We have AM, this is 5 because that whole thing was 10. And now we're going to be finding our mystery side here. So again, we're going to have to use the Pythagorean theorem. This is our right angle, so we're going to assign this is A, this is B, this purple line right here, the height, and the hypotenuse, which is across from the right angle, is C. So I have my A looking for B, and I have my C. So let's substitute those in again into the Pythagorean theorem. A squared plus B squared equals C squared. So my A was 5 squared. I'm looking for my B, and my C was 13 squared. And so this is going to be 25 plus b squared equals 169. Let's do a little bit of algebra manipulation here. So b squared comes out to be 144. Undoing the square root, we take the inverse operation, which is undoing the square, we do the inverse operation of square root, so b comes out to be 12. And so b, which is the height, that is Vm, sorry, move it down, Vm right here, that is the height, that was our b, so our height is going to be 12. I'm actually going to write that in. Our height is 12, which is the distance between v and m. So on our line down here, now remember, if you like the Pythagorean theorem and it comes really easy to you, make sure you attack this problem, but make sure you attack it and then complete it correctly. So when they asked the distance between v and m, I'm going to write down Vm equals 12, and then I'm not going to forget to put centimeters, because I'm going to give the answer just like they gave it up here. A and B equals, the distance between A and B equals 8 centimeters, the distance between B and C equals 6 centimeters, so I'm going to relay the answer just like they gave it to me up there. Okay, let's see what they want us to do for part B. Part B is calculate the volume of the pyramid. So this is where you go back to your, please take out your formula booklets, your green formula booklets, and you're going to be turning to page 5 in your green formula booklets, and on page 5 you're going to see the volume formula is 1/3 area of the base times height. And next to this formula, can you please put down paper 1, example 9, because that's where we're using the formula. You're going to that formula booklet and you're using the volume of a pyramid formula, and it was for example 9. So please pause and take a second to take out that formula booklet, and next to the volume of a period formula, put down P1 EX9. I would also, since you're in your formula booklet, I would also, inside that booklet, annotate. This capital A, that is the area of this rectangular base. The area of a rectangular base is length times width. And you're going to find the length and width meeting at a 90-degree angle. So this A is really length, and this B is really width. So please annotate that in your formula booklet as well. Then we'll be ready to go. Okay, let's calculate the volume of the pyramid. So this is going to be part B. I'm going to do it down here, part B. So the volume of the pyramid was 1/3 times the area of the base times the height. So our volume is going to equal, now I'm going to put this 1/3 in parentheses because I'm going to just type it into the calculator all in one line, times, now area of the base is length times width. We have length, which is 8, times, we have width, which is 6, and I knew there were length and width because they were the ones that meet at the right 90-degree angle, times the height, and the height we found, the height is 12, times 12, and that's why I actually wrote it down here, is to remind myself that's where it is. So now in my calculator, what I'm going to do is parentheses 1 divided by, let's push the division symbol, 3, close my parentheses, times 8 times 6 times 12, and that's going to give us 192. And so I'm going to write down V equals 192. Now again, this, if you like these types of problems and they come easy to you, make sure you do them, but you also do them right and record their answers correctly. And so we can put down 192 centimeters cubed. And you cannot forget that little centimeters cubed. The reason why it's cubed is because we're multiplying 3 dimensions. We're multiplying length, we're multiplying width, and we're multiplying height. And 3 dimensions gives us the volume of a, for in this case, pyramid. This has been paper 1, example 9. Geometry problem. We calculated the distance between V and M, which is the height. Recorded it as 12 centimeters. We calculated the volume of the pyramid using our formula booklet. We located the formula. We substituted in the 8, the length, the 6, the width, and 12, the height. Used our calculator and reported it out as 192 centimeters cubed. Hope this helped. Good luck on your papers.